I made a slight error in the electron transport chain video, and I wanted to correct it in this one. And it's also an opportunity for me to include a little bit of terminology that I forgot to include in that video. So when I described the electron transport chain, we remember it's just you have some high energy electrons in NADH, and they get transferred from one molecule to another, and as they get transferred, they go into lower energy states, and they release energy. And then the final electron acceptor was oxygen. Oxygen got reduced right here. But if you look at both sides of this equation, the mistake was I need two hydrogens. If I have two hydrogens on the right-hand side in the water, I need two hydrogens on the left-hand side. So there should be a 2 right there. So that was what I would consider to be a minor mistake in the last video. But this also gives me a chance to introduce you to some more terminology. So this whole process, we know that this is called oxidation, right? When NADH loses a hydrogen, remember oxidation is losing formally electrons, but when it loses the hydrogens, it loses the opportunity to hog that hydrogen's electrons. So this whole process of the electron transport chain is one molecule after another getting oxidized until you have a final electron acceptor in water. So this is obviously, you could call this oxidation, just very generally. And then the second part of the electron transport chain, or maybe we shouldn't even call this part of the electron transport chain, the process where the ATP is actually formed, the adding of a phosphate group to another molecule is called phosphorylation. Phosphorylation. So the whole process of creating ATP through the electron transport chain. Remember, the electron transport chain releases energy that creates this hydrogen gradient. It pumps the hydrogens into the outer compartment, and then that gradient, those hydrogens that want to get back into the matrix, essentially go back through this ATP synthase. This process of generating ATP this way is called oxidative phosphorylation. Oxidative phosphorylation. It's a good word to know. You might see it on some standardized tests or on your exams. And it's called this because you have an oxidative part. Each of these molecules get oxidized in the electron transport chain as they lose their hydrogens or as they lose their electrons. That creates a hydrogen gradient. And then that, through chemiosmosis, allows for phosphorylation. So that's another good word to know. The transfer of these hydrogens, these kind of going through this membrane selectively. This membrane, this ATP synthase wouldn't allow just any molecule to go through it. It's allowing these hydrogen protons to go through it. This process right here of this hydrogen going through it is called chemiosmosis. Chemiosmosis, another good word to know. So the entire process called oxidative phosphorylation, they don't happen at the same time. Oxidative generates the energy because the energy to push the hydrogens out, and then the phosphorylation happens as the hydrogens experience chemiosmosis and go back in and turn this little axle and then push the ATP or the ADP and the phosphate groups together. And then you can contrast that with substrate phosphorylation, since I'm in the mood to introduce you to terminology. Substrate phosphorylation. This is actually what happens when the ATP is produced directly in glycolysis and the Krebs cycle. So this is in glycolysis and the Krebs cycle. And this is where you have an enzyme directly helping to produce the ATP without any type of chemiosmosis or proton gradient. So if you imagine an enzyme, some big protein blurb, and let's say it has the ADP. So it has the ADP there with its two phosphate groups, and then maybe it has another phosphate group that attaches at some other part of the enzyme. This enzyme facilitates without any kind of chemiosmosis or oxidation. It facilitates probably in conjunction with other energy releasing reactions that maybe are occurring at other parts of the enzyme. So maybe you can imagine a little spark right there, and then that twists this entire enzyme. This isn't exactly how it might work, but it's a good idea. And then these two things maybe get pushed together. When it's just an enzyme without any of this chemiosmosis that's driven by oxidation, like we learned in the electron transport chain, we call this substrate phosphorylation. And then the substrates are just the things that attach to the enzyme and have something performed on them. So anyway, hopefully you found this little video mildly useful.